Hello, welcome to my Module 6 experiment video, where today we'll be investigating electrostatics using tape over 3 parts. For the first part of this experiment, we'll be attaching a tape on a table, as shown in the following image, peel it off and attach it on a wooden cooking utensil. We'll then bring both a pen and my hand next to the tape without making contact between the hand/pen and the tape to see what happens. So we'll be taking the tape at the bottom, we'll peel it off, and we're going to attach it to this cooking utensil right here. And as you can see, if we bring our hand next to it, the tape gets attracted to us. And if we bring our hand on the other side, it gets attracted to us as well. Same thing goes for the pen. You bring the pen next to it, it gets attracted, and then the other side it gets attracted as well. So we'll put this on the side for now, because we'll move on to the second part. For the second part of this experiment, we'll be taking another tape and repeat the procedure from the first part, but this time we'll bring both tapes together, again without any contact, and see what happens. So here I've attached one of the tapes, the other tape to the wooden utensil, and we're going to bring them together, and we're going to see that these two tapes repel each other. No matter how close I try to get them to be, they're just not getting closer to one another at all. Just kind of dancing around. Right, so we can see that the hand of the pen attracted the tape, whereas the two tapes repel each other. So the reason for these set of observations are simple. As the tape is peeled off the table, it also removes some electrons from the surface of the table. This excess of electrons causes the tape to become negatively charged. When we brought two tapes that were both negatively charged because of our procedure, they repelled each other since like charges repel. To explain why the hand and the pen were attracted to one of the negatively charged tapes, we need to understand that the negative charge of the tape causes a rearrangement of the centers of charge of the atoms and molecules that compose the hand and the pen, since the electrons orbiting the atom get slightly attracted to or repelled from the tape, depending on the charge of the object. In this case, they get slightly repelled since the tape is negatively charged. This causes one side of the atom or molecule to be induced into becoming more negative than the opposite side, that in turn becomes more positive than the other. When this happens, the object in question becomes electrically polarized. In our procedure, both the pen and the hand were electrically polarized. Now with that done, we can move on to the third part of our experiment. For the third part of this experiment, we placed a total of 4 tapes. We placed 2 tapes separately and directly on the table and have labeled them B for bottom, and we placed 2 separate tapes directly on top of the first 2 tapes and have labeled them T for top, as shown in the accompanying image. We're going to first peel off one of the bottom tapes and then from the table, and then peel off the T tape attached to it, making sure to place each of the 2 tapes on wooden utensils, like so. Oh, don't do that. I'm gonna have to do this one like this. Oh. Hopefully that doesn't affect it too much. Okay, put this one like this, and there we go. Okay, and then we're going to repeat the same thing for the other 2 tapes. So we're going to take the bottom tape first, we're going to peel that off, and then we're going to take the top tape and we're going to peel that off too. And we're going to put bottom tape on the utensil over here, and then we're going to take the other utensil and take the top tape and put it over here. And next, we're going to take a pair of each of these 2 tapes, and we're going to see what happens. So first we're going to take the 2 bottom tapes together. So you can see B for bottom and then B for bottom. And as we bring them close to one another like this, you will see that they kind of repel each other. They're doing their little dance as we should expect. Obviously, we're trying to avoid them sticking together, but you can see that if I keep this one still, bring this one closer, it deflects a little bit. So that's what happens for the two bottom tapes. Now we're going to take the two top tapes and, oh gosh, hopefully that doesn't do much. And we're going to bring them both together and we're going to see what happens. So as you can see, they also repel each other. I bring this one close to the other one and it literally flies high like so. Let me quickly fix this. There we go. Okay. Lastly, we're going to bring both the bottom tape and the top, a pair of a bottom tape and a top tape together and see what happens. So here we have top tape and here we have bottom tape. And we are going to bring these two together, and as we can see, they already just attract each other. Like if I bring this one to this one over here, it's just gonna connect. Like so. It's bringing it closer. And if we bring the other set of the bottom and top tape, we're going to see the same result. So we're gonna see that they just get attracted to one another instantly. So to explain what's happening, just like in the first two parts when we peeled off the bottom tape from the table, the bottom tape became negatively charged because it absorbed excess electrons from the table. When we peeled off the top tape from the bottom tape, the top tape then absorbed the electrons on the bottom tape and then some more, causing the top tape to be negatively charged and the bottom tape to be positively charged due to a lack of electrons. As such, the two bottom tapes and the two top tapes repelled each other since like charges repel, the former having positive charge and the latter having negative charge. And for the bottom/top tape, they attracted each other because unlike charges attract, as the bottom tape was positively charged and the top tape was negatively charged. With those three experiments done, we can answer the following three questions. First, what is the minimum number of types of electric charge and how do you know that from your tape experiment? Well, the minimum number is 3. You have positive, you have negative, and you have neutral. Neutral is simply when an object doesn't have a charge, like an overall charge. So example, you can bring a wooden spoon next to a wooden spoon and they're not going to attract each other. But you also have positive and negative, and you can see that specifically from the third experiment, because you had that the bottom two tapes repelled each other, the top two tapes repelled each other, but then the bottom tape and the top tape attracted each other. If you had that it was only one type of charge responsible for that, then you should actually have the bottom tape and the top tape repelled each other. Since the bottom tape and the top tape would have the same charge. However, the fact that they attracted shows that there has to be at least a positive and a negative charge. Specifically, the bottom tape had a positive charge and the top tape had a negative charge. Secondly, what forces do electric charges exert on each other, and how do you know that from your tape experiment? Well, we know that electric charges exert attractive and repulsive electrostatic forces. We know this because the mass of the tapes is not that large, so gravitational forces are not responsible for why the tapes attracted to each other. And also gravitational forces do not repel, they're not repulsive. So we know that it was another type of force, specifically the electrostatic force. Thirdly, how does the magnitude of the electrostatic forces that charges exert on each other depend on the distance between the charges, and how do you know that from your tape experiment? Well, as the distance between the charges increases, the magnitude of the electrostatic forces that the charges exert on each other decreases. We can most easily see this from the first and the second experiment. As for the first experiment, the tape did not get attracted to either the hand or the pen until they were both brought very close to the tape. And for the second experiment, the two tapes didn't repel each other until they were brought close together. This is what we should expect according to Coulomb's law. which states that the electrostatic forces between two charged objects is proportional to the product of the charges of the object and inversely proportional to the square of the distance between the objects. Thank you for coming to my Module 6 experiment, and I hope you guys have a good time.